Well, hello, honors geometry students. Oh boy, am I excited about today's lesson. Look what I just got out of the oven. And I never can wait. Do you ever have that where you get them out of the oven and you know they're really, really hot, but you just can't wait to have a little taste? But if you tried to eat the whole cookie right now, it wouldn't work. So here's my secret. I just cut a little piece off. Whew, hot, 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 hot. And I throw that little piece right in my mouth. Ooh, it's still hot, but So this is what we're going to be studying today. 12.3, and we're going to also look at some radians today. What I just cut off is one of our vocab words today. Now, you know what the segment itself is called because it went from one point on the circle to another point on the circle. It's kind of hot, so I can't really show you too well, but that's obviously what? A chord. But now I ate the chord and all the arc around it, which is also what I left, a chord and all the arc around it. So what I just ate is called a segment of a circle, or in this case, the segment of a cookie. So that's what we're going to be looking at today, segments of circles, segments of cookies. Now, I'm going to put these over here and eat those after a while when they get cooled off a little bit. But I did make a cookie that I can touch a little bit better, and I made it big enough where you can see it. So what I just did is to say, okay, I have the whole cookie, and I cut off this piece that is the segment of the cookie. So again, the segment of the cookie is from the chord all the way back around on the arc, okay? And by the end of the day, then we're going to figure out how can we find the area of this? What will we need? How will we find it? But before we do that, we want to look at it in terms of what we had from last week. We said we knew that that was a chord. What kind of angle is it if I go to the center of the circle? So if I cut that, what kind of angle is that called? You remember? Now we're going to be looking a lot at this vocab. So if you don't remember the vocab from last week, major arc, minor arc, chords, secants, tangents, that's going to be talked about the whole rest of this chapter. So make sure you go back and review that. This is called a central angle, and you need to remember that a central angle is equal to its arc. So what we're really going to be looking at today is to see if I just had a 120-degree arc measure right here, okay? And I know that my radius here on this cookie is quite large. Let's say the radius is 3 inches, okay? Now, if that whole cookie had 200 calories, how many calories would I be eating in this part? Think about that. Let's see if we can figure that out as we get through some of the basics here today. So go ahead and take out your notes, and remember to put your notes with the reteaches so that I can give you credit for everything here in your notes and reteaches at one time. Okay, so 12.3 we're going to be looking at, and then we'll be looking at also some radians and what does that mean. So 12.3 is sector area and arc length. So basically the sector then is just that same thing as what we just looked at. It's just saying, okay, the sector is the whole piece of pie. I like to think of it as a piece of pizza, although I don't have a pizza right here. That'd be nice too, huh? But if you had a piece of pizza, most pizzas are cut to the center. So the piece of pizza is my sector. Now remember, it's part then of the area of a circle. So if you think about this, again, it's just kind of review. The area of a circle is pi r squared. So we would know it's part of pi r squared. And since it is an area, it's going to have units of square units. Whereas the arc length that we're going to be working with is going to be not part of the area, but part of the outside. It'd be like if I wanted to frost the outside, or I only wanted to eat the crust or not eat the crust on a pizza. That would be the arc length. So the arc length is part of the circumference. So the units for arc length then would be in linear units. So it would be like in inches or feet or something like that. Okay? And of course then circumference, we have to remember, is 2 pi r, or pi times diameter. So a lot of review in this as we look at our sectors and arc lengths today. Remember what we talked about last week also, that arc measures are going to be in degrees, or we're going to find out today that we can measure them also in radians, and that they're always 360 degrees in a circle. So we need to make sure we understand that. Okay, let's go ahead and try then looking at our sector area, okay? And again, if you just think about it, it's really not like you have to learn a whole lot. It's just a little bit of symbol maybe, but if you think about it, you'll be able to catch on to this right away, okay? So our sector area, think of our piece of pie, think of a piece of pizza, think of our cookie that I just cut from the radius to the radius. Our definition is just going to be a sector is 2 radii, okay? So it's going to have to go through the center to be the radius, and the arc between them. So it wouldn't matter if I did a diameter.
I'm having trouble hearing you.
Oh, I guess they thought I was saying something else instead of sorry. So if I look at that as a diameter, that's still 2 radii. So I would still end up with having a sector right here. Now think about that then. This is the sector, symbol-wise, sector PQR. So our symbol for a sector starts with a point on the circle, ends with a point on the circle, and then the middle letter is always the name of the circle, the center of the circle. So our sector PQR. See, I probably don't even need to teach you at all. You would already know that because you know the whole area of the circle is pi r squared. Well, the radius is 10, so it'd be 100 pi. Well, if the whole circle is 100 pi, what do you think this sector is? You're exactly right, 50 pi. And remember, if that were in inches, it would be in square inches. You see, it's really not all that difficult. It's just some kind of like common sense. Just kind of think about it. Okay, so you don't have to derive a formula that way. So I'm looking at saying, okay, what would I call this sector? You're right, it would be either SQR or RQS. Any ideas what the area of this sector is, since I kept it with the same radius? You're exactly right. It's going to be 1/4 of 100 pi. So this one will be 25 pi square inches. Let's say it's in inches. Okay? So what happens then when it's some random number, like I put 70 degrees here? Is that going to make it more difficult? No, you're really just going to say your sector area is just whatever the part is times the area of the circle. So how am I going to find the part? Well, here it was 180 out of 360, or half. Here it was 90 out of 360, or 1/4. What is it here? You're exactly right. So all I'm going to do is say 70 out of 360 times the 100 pi. And that would be how I find my area of my segment, or the sector of a circle. So not too bad in finding sector area. So what happens when we go back to that? How am I going to find that segment area? Well, let's see if that makes it a little more difficult. My segment area. I can flip this around here. So my segment area, well, what did I cut off? You're exactly right. I just cut off the edge of that sector. So basically, I'm saying that if I want to find the segment area, I'm finding the chord and its arc, okay? But that's going to be the sector minus what shape? The sector minus what shape? Okay, in every single case, these are all segments of the cookie, and then it's just the sector, and you got it, minus the triangle area. So again, a lot of review. You're just saying, okay, how could I do the sector of the cookie, and then how could I find the area of a triangle? Okay, so let's just take a look at doing this middle one again. Well, we already found the sector area. That's the one we just did, 1/4 of 100 pi. So that we came up with 25 pi. And now how do I find the area of a triangle? Exactly, it doesn't change. It's still 1/2 base times height. Okay, so if I end up with a right triangle, what are the base and the height? Yeah, remember that all radii in one circle are congruent. So I would be able to say this is also 10. So 1/2 of 10 times 10. And my answer would be 25 pi minus 1/2 times 10 times 10, or 50. And it is still area, so it would still be in square inches. Now, can I add the 25, or in this case, subtract the 25 pi and the 50? No. This would be my exact answer. There's nothing else I could do with it. Now, if they want it rounded, obviously just put it in your calculator and it would still be in square inches or square units. Okay, so really not too bad, our segment area and our sector area. So let's go back to that original cookie and see what happens in the original cookie that I had where I said it was 120 degrees central angle. How would I find the area of this? And we had a 3-inch radius, okay? So now we've got to have 3 inches for both our radii, but this is 120 degrees. Could I say this is 3 inches also? Well, I could definitely do the sector area, because if this is 120 degrees, this is 120 degrees, so I could say the part is 120 degrees out of 360 degrees, or 1/3 of pi r squared, 9 pi. So 1/3 of 9 pi, 3 pi for the sector area. Now, what would I need to do to find the segment area? I gotta subtract the triangle, okay? So let's change colors. How am I gonna find the area of this triangle? You're right, 1/2 base times height. Could I do half of 3 times 3 though? Okay, because remember, when I do 1/2 base times height for my area of my triangle, that my base and my height have to be perpendicular to each other. Any ideas? I think you're catching on. Okay, so I know that my hypotenuse is 3. I bisected, so what kind of a triangle do I have? I have a 30, 60, 90. So you're going to be looking for 30, 60, 90s, or maybe 45, 45, 90s, or maybe some trig in this lesson today. So if this one is 3, then the short leg would be half of that, so 1.5. And the long leg, 1.5 times the square root of 3. Now remember, that was bisected. So what is my base area, or my base? 3 square roots of 3. And of course my height is 1.5. Okay, so I'm just going to do half of 3, which is 1.5, times 1.5, so 2.25 square roots of 3. Now that's just the area of the triangle. So how am I going to find now, if I know my sector area and I know my triangle area, how am I going to find that piece of cookie area? You're exactly right, just subtract. So my answer is going to be 3 pi minus 2.25 square roots of 3. And that would be in square units, so in this case in square inches. I can't add or subtract in this case because they're not both like units. Okay, let's move on to our last part here, arc length. I think you'll find that to be fairly just what the definition is too. Remember, the definition of an arc length is that it's part of the circle. But I do want to also talk a little bit, so you're not deceived here, in looking at saying if 2 arcs have the same measure, would the 2 arcs be congruent? If 2 arcs have the same measure, would the 2 arcs be congruent? Now, a lot of people get confused on that, because if 2 angles have the same measure, the angles are congruent, right? If 2 segments have the same length, the segments are congruent, but not so with arcs. Now, you can kind of see what I'm talking about. There's my central angle of 90 degrees, so obviously my arc is 90 degrees, so this arc from A to B is 90 degrees. But is that going to have the same length as this green arc from C to D? Obviously not, even though it's still a 90-degree angle. So just because the arcs are congruent or have the same measure, that does not make them congruent arcs. Okay, so be careful. Arc length is not the same as arc degree, okay? And I can have the same degree and have 2 different lengths. So arc length depends upon the radius of the circle and the degree of the arc. So make sure that you're looking at that. Okay, let's take a look at arc length then. And my arc length here, I think you'll find to be basically what we were just looking at. But instead of the area of a circle, what's the length of the arc? So now we're looking at the outside of the arc. So when I look around the outside of the arc, am I going to be working with area? Obviously not. Arc length is going to be part of the circumference. So as we were just talking about, it's really not too difficult here. If I said the whole circumference here, this is 10, so my diameter would be 20. So my circumference would be 20 pi. This arc length, you got it, would be 10 pi. Now would that be in square units? No, of course not. Going to be just in units. What about this one? You're exactly right. 1/4 of 100 pi, 20 pi. So I have my diameter is 20. 1/4 of 20 pi would be 5 pi inches. And what happens when we're back to, what did I put there, 60 degrees? You just have a little bit of a fraction. It's still a part. In this case, 60 over 360, or 1/6 of my whole circumference, which again was 20 pi. So 1/6 of 20 pi would be 26, or 10/3 pi. Okay, so really not too difficult at all. The length of the arc in this textbook is written as L. Okay, so I guess I put it there instead of down here. So that's the answer for L. And the length of arc DC, I put it up here, is 5 pi. Okay, now I'll give you a lot more examples as we look at the reteach worksheets. So when we get to the reteach worksheets, I'll look at those examples. But time for our little pun for the day. Did anybody get it? Of course. You guys are really good at these puns now. The pun was, what do you call the force on the surface of a balloon? What do you call the force on the surface of a balloon? Sphere pressure. You know, sphere pressure. There you go. Okay, so this week, the joke is, why was the cord upset with the tangent after the race? Why was the cord upset with the tangent after the race? Okay, email me your answers. You guys are getting really good at this. Okay, and let's go ahead and conclude then with the last thing that we were looking at, the extension on radians. Okay, what in the world is a radian? So let's put all of our circle work away and let's take a look at radians. First of all, radians are just another way of measuring. So it's not going to be too difficult. So it's just an extension. It is in your textbook, and I will give you examples in the guided practice. So a radian, remember on our calculator, it was RAD. So we're talking about those radians. A radian is based on the radius in a unit circle. So it's easy to think of. Radius, think radian. Radian, think radius. That's how it was named. Can you see the similarity? Of course you can, okay? So if I wanted to say, let's find 45 degrees in radians. Now we're just saying, I'm just measuring it in a different way, okay? So if I am looking at a unit circle, unit means what? Units place. And you got ones place. So if I say, okay, I want the unit circle, we're really just talking about a circle where the radius is 1. Now, to look at it and convert it to radians then, we're just simply saying, what would the length of this be in radians? So we're looking at saying, oh, the circumference of a circle is 2 pi r. So if the radius is 1, what's the circumference of this whole circle? 2 pi times 1, or 2 pi. So it's very, very easy then. We just look at it in terms of our radius equaling 1 unit. So 45 degrees then, how am I going to do that? Well, think of it like this. If I know that the circumference of this whole circle is 2 pi, then 360 degrees is also this whole circle, right? So all we're doing is saying 360 degrees then is the same as 2 pi radians. We usually use that RAD for radians. Get it? Or we can say, oh, well, that means if I divide everything by 2, so we don't have to have that 2, that 180 degrees would equal pi radians. Okay? So if I'm looking at this, I'd say, oh, that means that if I say that's pi radians, if I went all the way across, then 180 degrees would equal pi radians. Let's keep going. What happens if it's 90 degrees? Well, if this is pi radians, then this is going to be pi, what? Halves radians, exactly. Okay? Makes sense? Now, think about the relationship between 45 degrees and 90 degrees. What are each of these going to be? A half of that. Pi over 4. So 45 degrees in radians is pi over 4 radians. Now, we don't really want to use that for every single problem or conversion. So we're going to be looking at it and saying, well, let's just put these conversions from this. If 180 degrees equals pi radians, what would 1 degree equal? You know, divide both sides by 180. 1 degree would equal pi divided by 180 degree radians. All I did was take this, so I just always go back to saying my unit circle is the radius is 1, so my whole circumference is just 2 pi, and then I just divide it on out, or I say every degree is pi over 180. So there's the conversion. What if I'm given radians? Well, do the same thing, but this time let's just divide, so we have just 1 radian. So what I need to divide by to get just 1 radian on this side? Exactly, divide by pi. So 1 radian would equal 180 divided by pi degrees. Make sense? Okay. Now, again, I'm going to give you some examples from the reteach, but I made it as a worksheet, so make sure you get your radian worksheet. Now, I want to summarize here. I know it gets a little long, so make sure everybody's got it here. Here's the summary for the week, and make sure that makes sense now. These are basically the formulas that you're going to need to do on this homework. So the sector of a circle looks like a piece of pizza. I'm just taking the area of a circle and multiplying it by the part. So that's m degrees out of 360 degrees. Then if I only want the segment instead of the whole circle, I simply say, okay, the segment would be like the whole sector, subtracting off the triangles. Remember to look for the base and the height. That's not always the 2 radii. You might need to use those 30, 60, etc. And the arc length, which they use in this book as capital L, is just going to be 2 pi r times the part. 2 pi r coming from the circumference. So again, not things you have to memorize. These should be things that you already know. And then, of course, it's the same part as what we have up here. So the hard thing to remember is, am I going to be working with arc length, or am I going to be working with area sector? So remember, area, part of the area of the circle, length, part of the circumference of the circle. And then our last ones, radians. If I'm going degrees to radians, I simply multiply the degrees by pi times 180, pi radians divided by 180. Multiply the degrees by pi radians over 180. And if I want radians to degrees, I multiply the number of radians by 180 over pi radians. And again, I'll give you more examples of that. And once you see the examples, you're going to say, oh, that's all you have to do? And I'll say, yes, that is all you have to do. I hope you have learned something today, and I hope you have a great time practicing. But don't forget, as you practice and you have any questions, you can always email me, you can always call me. I'm here to help you. Have a good week learning geometry.